All right, so we're on 1.7, and they've got 4 different properties listed here. So let's zoom in on the first one. So the first thing we're going to talk about is the commutative property. So let's see, how do I do this again? So the commutative property right here, oh, that's way too wide. Hold on. Let's try that. There you go. All right, so commutative property. What that says is you can add or multiply in any order. Like, you guys, if you do 5 plus 2, that's the same thing as 2 plus 5, right? Both of those are 7. Same thing if you multiply. You can multiply in any order also. Like 5 times 3, that's the same thing as 3 times 5, right? They're both 15. So that's what the commutative property is. So that top example there, this one, that's the commutative property for addition. The bottom one is the commutative property for multiplication. Now, would those work for subtraction? Could you have a commutative property for subtraction? Like if I did like, what could I do? So like if we did like 10 minus 2, would that equal 2 minus 10? No. No, the left side would be 8 and the right side would be negative 8. So there is no commutative property for subtraction. So that doesn't work. What about for division? If I did 10 divided by 2, would that equal 2 divided by 10? No. No, 2 divided by 10 on the left would be 5, and on the right you would have, or I don't know if I said that right. 10 divided by 2 on the left would be 5, but 2 divided by 10 on the right would be 1/5. So no, there's no commutative property for division. So you can only switch, in other words, you can add or multiply in any order you want, okay? All right, well, let's look at the next one. So the next one is the associative property. So let me slide this up. So the associative property, that's that right there. What that's really about is that's really about regrouping. Can you guys see on the first example for the associative property of addition? Can you guys see that on the left, inside the parentheses, you have 1 plus 2, but on the right, you have 2 plus 3. Now, can you guys see that all they did was regroup? So in both of these in this example, you still have the same numbers, right? You have 1, 2, and 3, and on the right, you have 1, 2, and 3. But you just changed what's inside the grouping symbols. So if you do that, that's the associative property for addition. And you can see that the two sides are equal, right? The next example is the same thing. You got the same numbers again. You can see you got a 4, a 5, and a 3, and a 4, and a 5, and a 3. But again, all they did was change what's inside the parentheses. So on the left, the 4 and the 5 were grouped together. On the right, the 5 and the 3 were grouped together inside the grouping symbol. But you should see that that's a true statement, right? So if we did what was in parentheses first on the left, 4 times 5, that's 20. We'd have 20 times 3. And on the right, if we do what's in the parentheses first, we'd have 5 times 3 is 15. And that would be times 4. Are those two sides equal? Does 20 times 3 equal 4 times 15? Yes or no? What do you think? Yes or no? Are those equal?
Yes.
Yeah. Yeah, 20 times 3 is 60, and 4 times 15 is 60. Okay? I'm not going to show you right here, but I think there's a problem in the homework. There is no associative property for subtraction, and there's no associative property for division. Those do not work. Okay? So that regrouping idea, that only works for addition and multiplication. And then the next one Have you guys done the distributed property before? Let's slide up on this one. So the distributed property, they show it symbolically there, right? Yeah, I should say that too, is when you look at these in the book, sometimes they just show you without numbers, okay? Let's go back for a second. If you look at that associative property right there, you can see that with simple numbers like 4, 5, and 3, it holds true, right? But now when you see that in the book, it might look something like they'll have like, I don't know, A plus B plus C. And on the other side, they'll have A plus B plus C. But then on the left, they will have the A and the B grouped together. And then on the right, they'll have the B and the C grouped together. So you should be able to recognize it like that also. Okay? In other words, let me fix this part a little bit. That's A plus B in parentheses and then plus C. So you should be able to recognize those properties without numbers, okay? Just with variables in there. Or just with symbols. But that is still the same property that you have right here. That's the associative property for addition. Okay, now let's do the distributed property. So you can see this one, they didn't use numbers, they just used symbols, right? They just used variables. So we are doing the distributed property. And maybe I'll write an example next to it here. You guys are probably used to seeing it like something like, I don't know, what should we do? Let's do 3 times x minus 2. So when you distribute, you're going to do the 3 times the x, and you're also going to do the 3 times the negative 2. Thank you. So then what we'll get? Well, what's a positive 3 times positive x? Guys, what's positive 3 times positive x? Yeah, positive 3x. So that gives you a 3x. And then for the second part of it, what's a positive 3 times a negative 2? We're doing positive 3. Remember, there's a multiplication right there. Yes. Good. Yeah, if you do positive 3 times negative 2, you get a negative 6. So we're just going to write minus 6 right here. All right? So that subtraction right there, that subtraction symbol, that implies that that 6 is negative. So that's probably more like what you're used to seeing when you talk about the distributed property. All right, let's move on to number 4. So in number 4, we're going to combine like terms. Terms are separated by addition and subtraction. So let me slide up on this one. So again, we're doing like terms here. All right, now like terms, in order to be alike, the variable part has to match exactly, including the exponent, okay? And if they do, then you can add or subtract to combine the like, you can add or subtract to combine the like terms. But before we do this first one here, what number is in front of this x right here? Yeah, if there's nothing written there, then that's implied to be a 1. So that's a 1x. So we've got 1x plus 3x. So how many x's do we got? 4. Yeah, we'd have 4 x's. So the answer to this would be 4x. And then the next example, we've got, well, again, we'd have a 1, right? We'd have a 1 in front of this one. So we've got 1x squared plus 4 more x squared. So how many x squares do we have?
5x squared.
Good. Yep, so we got 5x squareds. And is there another example over there to the right? Yeah. Thank you.
Thank you.
The next one there, well, neither one of those has an x, right? So if they don't have an x, you're just adding the two numbers together. So that's just 8. So that one's going to be 8. Now let me put one more example up there. Let's say you had something like, I don't know, we got room over here to the side. Yeah. So over here to the side, let's do a couple. Let's say you had, I don't know, let's say you got 3x to the 4th plus, well, let's make it minus 2x to the 4th. So if you got 3x to the 4th, take away 2x to the 4th, how many x to the 4th do you have?
1x to the 4th.
Yeah, you got 1. And you don't need to write the 1 in front of it, so you just write x to the 4th. Okay, but now what if I give you 3x to the 4th minus 2x to the 3rd? What do you do with that one? Can you see that that's a 3 there?
Yeah.
All right. So what's 3x to the 4th minus 2x to the 3rd? What's that?
Can you even do it?
Say it again?
Can you even do anything?
No, you can't. That's the whole point. Yeah, those are not like terms, okay? You can only add or subtract to combine the like terms. They're only alike if the variable part matches, including the exponent. So since in this one the exponents don't match, then that's as far as you can go. So that is the answer. You can't do anything with that one. All right, and I think that's about it for the notes. We just got to go through the examples. All right, so let me slide this down a little bit. Okay, so the first one. Now, what this is an example of is they want you to do like mental math, but they want you to use those properties we just talked about to simplify the math so you can do it in your head, basically. All right? So what you want to, like, I don't know what 1/3 times 5 times 33 is, but if I can multiply in any order, right? So what they want us to do, now you might not even write this down, but I will just so you can see it, is you want to change the order on these two. Okay? So what you want to do is you want to make it 1/3 times 33 times 5. And the reason you do that is because you know that the 3 will divide into the 33, and you can cross cancel right here, right? So how many times does 3 go into 33? 11, good. So what you could do then is you cross cancel this. So 3 divides into 3 once, and 3 divides into 33 11 times. So now you got 1 over 1 times 11 times 5. So what's 11 times 5? 55. Thank you. So the point they're trying to show you here is that you can multiply in any order. So what you did is you used the commutative property of multiplication to reverse the order of these two. Okay, you switched them. All right, so let's do number 2. So number 2, it's going to be pretty easy to add the 55 plus 45, right? What's 55 plus 45? That's 100. And then 16 plus 4 is what? 20. So you should get 120. So if you guys see me on the board on a good day, if I'm doing a bunch of math in my head for you guys, like really quick, that's all I'm doing, is I'm just applying these properties. Now I'll write it out for you guys just so you have something in your notes. So what we're going to do here is we're going to commute these two, right? because you can add in any order that you want by the commutative property for addition. So real quick, we're going to rewrite this as 45 plus 55 plus 16 plus 4. And then you do these two real quick in your head and you get 100. And then you do these two really quick in your head and you get plus 20. And you get 120. Make sense? Okay, let's keep going. So number 3. So number 3, I do this all the time for you guys, okay? When I'm like, again, if I'm feeling awake and sharp, I do a lot of the math in my head for you guys or whatever without a calculator. So if I got to do 5 times 59, I don't do it like, remember how they taught you in elementary school? They would make you do like 59 times 5 like that, right?
Oh, yeah.
All right. Well, I don't do that. What I do is I do it like this. I use the distributive property in my head. I know that 59 is 60 minus 1. And then all I got to do is distribute this thing, right? And again, I would do this in my head. So what's 5 times 60?
300.
Yeah. So what you do is you do 5 times 6, and then you just add the 0. So 5 times 6 is 30, and then you add another 0. And then you do 5 times, or you do minus 5. What's 5 times 1? 5. And then you just do 300 minus 5, you get 295. Then number 4, that's more like what I showed you before. You just got to distribute. So you're going to distribute like this. All right, so what's 3 times 2? That's 6. And then what's 3 times positive x? That's a positive 3x, so you write plus 3x. And again, that addition symbol right there, that implies that 3x is positive. So there's that one. Is there another one over here? No. All right, number 5. So 5, again, I don't know what 8 times 33 is, but I'm going to use the distributive property to do this real quick in my head. So I'm going to do the 8 times 30, and I'm going to do the 8 times the 3. Okay? Because I can do 8 times 30 in my head, right? So all I'm doing is I'm rewriting that 33 as 30 plus 3. So if I want to do 8 times 30, I just do 8 times 3, which is what? 24, and then I add the 0. So I know that that's going to be 240, right? And then plus, what's 8 times 3? Yeah, so I'm doing this 8 times that 3 right there. That's 24. So then I get a final answer of 264. And like I said, I do that all the time in my head with you guys when I'm working on the board. So a lot of times, if you wonder how I got that answer so fast, again, I just in my head, I would break the 33 into 30 plus 3. Okay, number 6, we got 72 P's, take away 25 P's. How many?
47.
Good. Yep, that's 47 P's. So 47P. All right. Hold on, I just messed up. All right, number 7. It says I got 1/2 of an M plus 1/2 of an N.
No, it's
One and a
They both don't.
No, wait, they're not like terms.
Yeah, good. Yeah, they're not like terms, so you can't add them, you're done. All right. Now, if this right here was an M, if that was an M, then you'd have 1/2 of an M plus 1/2 of an M would give you 1 M, right? But it's not. These are not like terms. The variable parts do not match, so that is the answer. So this one's already done. All right. Then on number 8 here. On number 8, what am I going to do first? Good. Yeah, we're going to distribute. Okay, so we're going to do 4 times 2 is what? That's a positive 8. And then I got a positive 4 times a positive x. That's a positive 4x, so I write plus, right? So again, that addition symbol right there, that implies that 4x is positive. And then I bring down the 14x out in front. Yeah, so then the next thing you would do, what's that called? Yes, but what's that called? What do we do? You guys, what's it called? What are we doing? Yeah, combining like terms. That was that 4th property, right? So now on some of the problems on the homework, they want you to write down like what properties did you use. So the first thing we did was distribute, so you want to write that down, right? So let me do that on this one. So we distribute. And the second thing was we're going to well, you guys, now look at in the book, they would want you to commute these two. So they'd want you to switch the order on that using the commutative property for addition. And then after you did that, then they would want you to put the 14x plus the 4x in parentheses so that you would combine them. And then that would be the associative property for addition. But we're not going to do all that, okay? We're just going to distribute. And then I think you guys can see that you're going to combine like terms with these two, right? So you got 14x's plus 4x's. Yeah, that's 18x's. So you end up with 18x's, and then you bring down the plus 8. So that was combining like terms, right? So we're going to write like terms. So that was the 3rd and 4th properties that we started the lesson with. And then can I go any further? No. Now if this had an x, then we could, right? That would be 26x. Or if that didn't have the x, then we would do 18 plus 8, that'd be 26. But since it has the x, we're done. These are not like terms, so that's as far as you can go. And is that all of it? I think it is, isn't it? I don't know, what's on the next page? Yeah. All right, let me stop the recording.